All right, so those were the two diffraction-based techniques, XRD and neutron diffraction. There are others, but those are by far the most common. Now we're going to take advantage of the fact that light is also a particle, and we're going to deal with different types of spectroscopy. And that's a good definition of spectroscopy. You know, before I was saying light interacting with matter, that's an okay definition, but you can see there's these diffraction things. People don't really call those spectroscopy. So it's really when you're taking advantage of light interacting with matter in order to probe matter, but the particle-like properties of matter. So this could be scattering, okay? Or this could be absorption. Most commonly, this is absorption, okay? And there's spectroscopies across the gambit, basically for every single energy regime of light, you have a different spectroscopy. So with the exception of gamma rays, okay, there are some, there's Moss-Bauer spectroscopy, which actually uses gamma rays. It's not really used too commonly, but X-ray spectroscopy, you know, wide range of different X-ray spectroscopy techniques. We'll talk a very little bit about those. Ultraviolet light and visible light, very common. Infrared light, you're getting, so what should I say? X-ray spectroscopy, you're probing core electron, so you're exciting, it's very high energy light, so you're going to be doing absorption events at core electrons. Core electrons are very stable, so in order to excite core electrons, you need a lot of energy, right? So X-rays, we're going to do that. If you go to ultraviolet, or visible light, that's less energy than X-rays. So you're talking about electronic transitions, but now you're talking about valence electrons, okay? Electrons involved in bonding, right? Infrared light, even less energy. And we know from our previous discussions on infrared spectroscopy that that all has to do with vibrations. You're going to be exciting vibrations, right? And so that takes less energy. And then you get into the microwave region, that's even less energy. There you're talking about exciting rotation. So there's rotational spectroscopies that you can do. And then even lower energies, you're talking about radio waves. And in radio waves, it's a little bit more subtle what you're doing there. We'll get into it when we talk about NMR, but you're actually doing nuclear spin transitions, okay, but that are very close in energy. And actually to get any sort of sensitivity out of this, you have to apply a high magnetic field, which you may know in NMR, right? You have these huge magnets. So in the survey spectroscopy, you know, all of these are photon-based techniques, right? We're using light and we're taking advantage of the fact that light is acting as a particle and mostly doing absorption techniques. The one exception to that is Raman spectroscopy, which is a vibrational spectroscopy based upon scattering, okay?